Hello everyone, I'm William Sacher. I'm a university professor at Universidad Andina Simón Bolívar in Quito, Ecuador. And the title of my talk is An Estimate of Future Social and Environmental Costs of Large-Scale Mining in Ecuador for a period of 1 century from 2020 to 2120. Ecuador is a sort of latecomer when it comes to large-scale mining exploitation. Even though we have more than 30 large-scale projects right now in portfolio, it's only very recently that the country has converted itself into a large-scale metal exporter, with only 2 so far large-scale mining projects in the extraction phase. Nevertheless, we have like more than 9% of the country which is already under concession by transnational mining companies, basically aiming at copper and gold as a metal objective. It is important to recall that the country is a host of a lot of endemic species. Many places in the country are actually classified as hotspot. It's a country of also high cultural diversity with more than 14 First Nation in the whole Ecuadorian territory. As it is the case usually, over the past decades, most of the activities carried on by mining companies consisted on exploration and adequating the material and socio-political condition on the ground to make the large-scale investments possible. For that reason, the country has known high and intensive mining conflictivity over the past decades, with all sorts of consequences, and particularly social consequences, social conflicts, but also dispossession, land dispossession, and other type of violence, ethnic violence, gender violence, and so on and so forth. As we can see with the previous map, most of the large-scale mining projects are located in the upper part of the watershed, either on the Atlantic or on the Pacific side. This is a very big concern for water resources, especially because Ecuador is an agricultural country, and it is highly documented in the academic literature that large-scale mining causes a series of damages to ecosystems, water resources, water quality, water quantity, and of course public health and economic activities. So the objective of the research was to carry on a so-called extended cost-benefit analysis. I have done so only for 10 of the 30 large-scale mining projects right now in portfolio. It is so because only for these 10 projects I was able to gather the necessary technical data to conduct the cost-benefit analysis. The most important data in my case was actually the tons of ore treated every day by the projects. So in the case of the projects that are already in the extraction phase, this is the actual data. And for the projects that are still in the exploration phase, these are the estimate of what would be the capacity of the projected mine in terms of ore processing. So here is a series of methodological features and issues associated to the work that have been carried on. First, as we are perfectly aware, it has been highly documented in the literature that cost-benefit analysis as a neoclassical and environmental economics tool is highly limited. There are strong limitations in the capacity of such a tool to represent social and environmental cost. Nevertheless, I have thought this work as a preliminary or a first step towards a more complete analysis of such social and environmental costs. Of course, in the study I'm presenting, I was not able to include all the costs and affectation that cannot be evaluated with the monetary language, such as biodiversity loss or loss of cultural heritage, for instance. But as I said, this can be a good first step and can even in that state represent some good insight in terms of what could be the social and environmental costs associated to the implementation of all these large-scale mining projects in the country. So by extended, I mean a cost-benefit analysis which includes a series of costs, of expenses and losses that are usually not included in conventional cost-benefit analysis. And this is the case of tax evasion, of preferential rates for instance, water or electricity. It is also the case for the monitoring of the abandoned mining site, and also the risks of accident, and particularly the risk of rupture of tailing dams, as well as the investments that are done by the state, usually under strong foreign debt, to develop the infrastructure that is needed by the mining companies to run the large-scale mining project. This is the case for energy infrastructure, for instance. So all these costs have to be included, and the hypothesis of the research is that by including all these non-conventional costs and losses and expenses, we might get some results that differ from the usual results of cost-benefit analysis. And the states has been used as an elementary unity at which costs and benefits are calculated. Here is a list of all the costs, expenses and losses on one side and benefits on the other hand that I have considered in the analysis I have carried on. In green you can see all the concepts I was able to include. In sort of reddish, these are all the concepts and lines of cost and expenses that I was not able to include so far in my analysis. This is not because I did not want to, it's just because I was not able to do it under the time I had on my disposal. So the prospective extended cost-benefit analysis model depends on a set of 10 parameters. Each of them can vary over a certain range. I have determined this range basing myself on values available in the literature. Each of these parameters has to be chosen for the prospective model to be run. I was able to test the sensibility of my prospective model to change of each of these parameters. And we'll see that we can get a spectrum of results, especially in terms of cost-benefit ratios. So here I present two specific scenarios, sort of typical scenarios. The first one, I have named it an optimistic scenario. This is a scenario for which the value of the parameters are quite conservative in terms of, the damage and the cost they're generating. And for this example, I was able to get a sort of almost even value between costs on one side and benefit on the other side. I get a cost over benefit ratio of 0.92. Of course, these are net present value in the tables, but as you imagine, these values are highly indicative and they are relying on the use of a certain discounting rate. Actually, the most useful results is associated to the ratio between cost and benefits that we get. Here is a graphic that illustrates the disaggregation of each of the concepts, either for benefits in blue or for cost, expenses and losses in red and reddish and yellow. And we can see for each of these concepts what is the share of each of them to the total either benefit or costs. Once again, for this optimistic scenario, we get an almost even result between costs on one side and benefit on the other. The second scenario, I have named it a realistic scenario. It is based on values of the parameters that are more common, or if you wish, correspond to more mean values available in the literature. In that case, we reach a cost to benefit ratio of 1.52. And you can see once again that I was able to produce some indicative value for each of the considered concept, either for benefit on one side or for cost, expenses, and losses on the other side. Once again, a graphical illustration of the results we get with this realistic scenario. By varying the 10 parameters on which the model relies, within their respective range, I was able to generate a total of 240,000 different scenarios. And here are the results of the cost-benefit ratios for each of these scenarios. I have actually drawn the statistics of it. And you can see that in 90% of the cases of all these scenarios, we have a cost-benefit ratio that is over than 1. And only in 10% of the cases, we have a cost-benefit ratio that is less than 1. So advantageous situation would be found in only 10% of the considered scenario if we vary the parameters within their respective range. So to conclude, we can say that the economic relevance of converting Ecuador into a large-scale mining country is, in the best case, ambiguous. As we have seen, in only 10% of the more than 30 scenarios considered, we get an advantageous cost-to-benefit ratio. What can be further said is that it is likely that further investigation and a more complete cost-benefit analysis that would include all the losses, expenses, and costs that have been left aside would lead to higher cost-to-benefit ratios and even a more disadvantageous situation in terms of statistics. Moreover, it can be said that a more complete analysis, for instance, multi-criterial analysis, that could be complemented by this sort of first step, which is constituted by this extended cost-benefit analysis, it is highly likely that in that case, we would get even more disadvantageous cost-to-benefit ratios. And what overall can be concluded is that Ecuador is taking a risky decision from an environmental and social cost perspective in converting itself into a large-scale mining country. Thank you for your attention, and I will be pleased to answer and listening to your comments and questions in this session.